Yesterday, we are working on time travel. So with the time travel, we can see the history of the table, what changes are happened, what operations are happened, how is the table structure or the table data at that point of time. We have seen all that. So we can access time travel with three options. One is with the query ID, one is with query ID, other is with the offset, and other is with the timestamp. So yesterday we are stuck at a timestamp using timestamp column. I'll show you now. So we can use two statements at or before in all of these queries, either with offset or either with the query ID or with timestamp. In any of these, we can use two things before. So before means what happened before this timestamp. If we say at the timestamp, what is the table structure at this point of time it will give. So before and at, it is just the English meaning. So now I will remove this timestamp and tz. If we don't use the timestamp NTZ, it will by default take the UTC time zone. So let us see how the table is with yesterday's date at this timestamp. This timestamp is UTC. So it says time travel is not available for table because at this point of time in UTC, our table was not created. So this is 5:31. This is UTC. At this point of time, our table was not created. So in order to convert this to the server time zone or our Snowflake account time zone, we have to use this timestamp tz. So at that point of time, our table is like this 2.5k rows we have. So I'll change the time to 5:20. So I'm checking over how is my table before this timestamp. Sorry, what happened? So before this 5:20, we have only 1.1k rows. So this is how with the timestamp we need to get our time travel data or the historical data. These are nothing but the snapshots. Snapshots in the sense, what is the table data at that point of time or before that point of time. Either it is offset or query ID or a timestamp. We can use all of this. So the time travel is set for 0 to 90 days. If you get this error like the requested, I'll show you this error. If you get this error, time travel data is not available for this table. The requested time is either beyond the allowed time travel period or before the time travel. So which means that we are accessing the data, which is now we have defined 5 days our time as our time travel for this table. So it might be that at this point of time our object does not exist, or it was more than the defined time period. We have defined 5 days only, but we might be accessing it for the seventh or the eighth day, 8 days ago. So it will not be able to get. So if the table is created within the defined time period, I mean timestamp, or within the defined number of days, then only we'll be able to get the time travel. So minimum for temporary table, time travel is not applicable. For transient tables, time travel is 1 day by default. So for permanent tables, we can define time travel from 1 to 90 days. So maximum limit allowed is 90 days. We can see what happened to our table within the 90 days. So now that 90 days period is over. Now let us say our table has updated 4 months ago, but 4 months is nothing but 120 days. But we are only able to see what happened in the 90 days. I wanted to see what happened at 100 days ago. So in those cases, we'll not be able to get it. It is only for 90 days. So there is a concept called fail-safe. Fail-safe, uh, it is extension to time travel. In reality, it is not an extension to time travel. It is used in case for some reason our data is lost for some reason, but we want that back. So in these cases, there will be a 7 days time period. After the expiry of the time travel, there will be 7 days time period in which we can get our data back. Let us say now I have dropped this table. This table has 5 days time travel period. I dropped this table somehow. I'm not able to access it anyway. So, but I need it really critical for my project. So in those cases, I will contact the Snowflake contact team. They will they will get this data. They'll take 1 or 2 days and they will provide that data within the 7 days. I mean, now let us say this is the fifth day our table is created. Let us now the table is created 10 days ago. I'm able to see what happened till 5 days ago, and this table is dropped. Now this table is dropped after 10 days, but still I want that table to get back. We need to contact the Snowflake team. If I contact after 1 week, they also won't be able to do anything. So after 1 week, they can't be able to do anything. But if we contact them within 7 days time period, they will be able to get it back. They have this backup for 1 month. Sorry, 1 week, 7 days after the data is destroyed. It is used in case of any. Uh, now the cloud account is hosted on some. Sorry, Snowflake account is hosted on cloud AWS, Azure, or GCP. Anything we have hosted on it. But in there is an issue in one of the servers. I mean, in the one of the cloud regions or the cloud availability regions, and our data is destroyed. There might be fire accident or something like that, and the data is destroyed. But we want that data. In those cases, we'll go for fail-safe. Generally, after the expiry of the timestamp, if we still want the data, we can go with fail-safe. That is for a 7 days period. Yeah, that is about the time travel. Now we'll go to Snowpipe. Snowpipe, yesterday we are not able to create a event notification. Now I'll show you. One second. Okay, first we'll create a Snowpipe object. It will be uh, in this database, and in this schema, I'll create a pipe object. Create a pipe. So they are giving the sample syntax. So I have prepared some files for the Snowpipe. I have already told the concept of Snowpipe. Till now, we have copied the data from S3 bucket to Snowflake using the copy command. So it is a manual process. Whenever there is a new file, we have to come to Snowflake, run the copy command. That is a manual process. But now my requirement is that as soon as there is a file in S3 bucket, it is coming through some code or something, it is automated process. Somehow the file is coming into S3 bucket. As soon as the file is there, it should be loaded into our table. That is the requirement. So for that, we use Snowpipe. Snowpipe is used for continuous data ingestion. I will create one more Snowpipe here. Snowflake S3 pipe. This is my pipe name. We have to enable this auto ingest equal to true. Then only the file should be loaded automatically. Then SNS topic is not required. Integration is also not required. Comment, this is optional, but I'll say creating a pipe. Creating a pipe. So inside what this pipe should do, it has to do the copy activity only, but on an automatic basis. As soon as there is a file in S3, the copy command has to execute. So I have some files. Uh, One second, Snowpipe. Okay, these are the files I have prepared. Let us say this is some orders table with the orders details, and every day the new orders keeps on coming. So every day the file will be placed in S3 bucket. As soon as it is in S3 bucket, it has to be loaded to our table. I will open a table and create. I will open this file and create a table first. So other than this date columns, other than these date columns, I will define everything as a varchar. Let us come to this copy later. I will copy this to Notepad. Okay, first create the table as per the file structure. I will name this table as orders, order details. Copy the column names from here. Stop me if you are not able to follow. There should not be any spaces in between the column names. Order ID, order date, customer name, city, country and region is in two different columns. Yes, region, segment, ship date, ship mode, state. Okay, I'll define everything as varchar now. ID should be 50 characters. Date is a date column. Customer name is varchar. See, let me see what is the date format here. It is in date, month, and year. I'll do this as varchar only. Varchar 20. Column I'll keep this as 20 characters. State, longitude, and latitude. Okay, these are our columns in the table. Database, schema. So this is the database and schema. Now creating the table. I have created this table. I want to load the data into this table. Now go to Snowpipe. Create pipe. It will give us the syntax. This is our table name. Copy into Snowflake S3 pipe orders. Auto ingest should be true. SNS topic is not required. Comment. This is comment is also optional, but I will provide it. Wait for loading orders. Copy statement. Here we have to write the copy statement. So the copy statement is just like how we have done it previously. I'll show you that. Copy. Yeah. See this? Copy into financial table from our external stage. So if we want to load the data from one of the cloud accounts, we need to create an external stage. We did it while running the copy command. So the same way, I'll just keep this copy command here. Copy into which table I need to copy? Here. Copy into orders table from where it should copy from the external stage. I'll show this stage. Our external stage name is this one. From @3 external stage. So inside this, I'm going to create a folder. This is our bucket. Inside this, till here we have given in the external stage location. I'll show you that again. This is the snow pipe. In this folder, I'm going to place those order files. I will delete this. Later, I will delete this. In this folder, I'm going to keep those order files. So till here, till Snowflake external files, it is already there in the external stage name. Only we need to provide the snow pipe. Now I'll provide here a snow pipe. So what are the files? Whatever files available in this snow pipe folder, it has to be copied in the file format. File format is CSV. So file format also we have a predefined file format which is load CSV. So this is our copy command. I'm creating this. So the pipe is created. Now go to projects. Let me show the pipes. Show pipes. Now we have two pipes. This is previously created. Ignore about this. Let us focus on this. Now we have created copy into orders from this location. This is the ARN. I will tell you what is the purpose of this ARN. Pipe for loading orders. We have given this as a comment. Now go to S3 bucket. So if we are putting the files manually here or day before yesterday, we have run the copy command to copy from here to there. I will delete this no sample file. Okay, now this folder is empty. I'll just place only the orders files. But before that, we need to automate that. How the S3 bucket triggers that pipe that we have to set. So this is the bucket that the trigger notification will be set on the bucket level, not on the folder level. It should be set on bucket. So I just, this is our bucket name. We have to go to properties, uh, come to create event notification. In this event notification, we have to write our event notification is trigger snowpipe S3. This is my event name. So prefix, I'll leave it as it is. Suffix should be option. Suffix is I have to load all the CSV files. All object create events. So these all options you can select based on your requirement. I will select this as the queue service. This is the service which triggers the pipe whenever there is a file in this bucket. So we have to select the SQS ARN. This ARN is nothing but the pipe ARN. This is the ARN. We need to copy it here for connecting Snowflake with this Amazon. I have created this, save changes. Now the event is successfully created. Now we'll keep the files in this folder. No, first I will load only one. First let us see in this table. Uh, 1 second, I'm getting it. Okay, sorry. So now we'll to see if there is any data or not. We did not insert anything, it will not be there. But let us see. Let's start from order details. So there is no data here. So in the pipes, we have two pipes. One is I have created myself. This is the one we have created now. So here we don't have any data. Now I will upload the files to this bucket. Under the snow pipe, I will upload. First, I will upload only one folder. Let us see what is the data available in this. Apply filter on ship date. This has all 2011 data. Only 2011 data is available in the first file. If you look at the file names also, same file. I mean, the pattern is same, just the change in real time, we'll get like this. Instead of 1, 2, 3, we'll get the date along with the timestamp. For simplicity purpose, I have given numbers for now. In the second file, ship date is, so it has, in the first file, we have data till September. In this, till September to 2012 data we have. So this is like incremental data. The first file has the earliest data, second file, some latest data. Like that, we have 6 files. I have total 6 files. Now I want to load all of them as soon as it is placed in S3 bucket. First, I will copy only the first file. I copied the first file. Okay, I copied this. Now we'll go to Snowflake. Pipes. So this is our pipe object in which the file has to be loaded. Here it says 0 files pending, last ingestion also nothing. So because the ingestion did not happen yet. Now go to projects. As soon as the pipe is created, it will not be working immediately. We have to refresh it. Refresh, sorry, alter pipe. As soon as we create it, it would be in suspended mode. We have to refresh that. Alter pipe, our pipe name is Snowflake S3 pipe orders. Refresh. I'm refreshing it. So after the refresh, one file is sent. One file is sent to this pipe object. Let us see the status of the pipe. Let us wait for 1 or 2 minutes. It will take some time to reflect here.
So we schedule these as snow pipes, right?
Sorry?
Do we schedule these snow pipes for
Yes, we can
incremental?
schedule. Yes, we can schedule it. I'll tell you, there is a separate concept for that scheduling. It is called task.
Because within Snowflake, we'll be scheduling this, or do we use any
No,
external
currently Snowflake is not scheduling. It is scheduled by this event notification by the
tool?
S3.
Okay.
So on the S3 bucket, we have configured a event notification. One second.
Yeah, I got it.
Yes, this is setting that pipeline. So it is refreshed now. Last ingestion is 1 minute, 1 seconds ago. Let us see in that table if the data is there or not. Go to projects. Yes. Now do select star from this table. So we have 501 rows. 501 because it did not skip header, it seems. We have 501 rows. Now again, I will load the second file. I will keep the second file in the bucket. So I have configured to put it in this bucket. So if only if this folder has the files, it will copy. Otherwise, it won't. I will copy the second file now. It will take care of the duplicates also. If the same file with the same size is loaded again, it won't load the data. It will eliminate duplicates as well. And even if the file names are different, but the data is same, then also it will take care of the duplicates. We don't need to do anything. It will itself take care of the duplicates. Now again, go to this. Let us wait for some time. It will again refresh. Yeah, 27 seconds ago because I have uploaded another file. Now we'll go to the query and see how many rows are there. So previously we have 501 rows. Again, I'm doing select star. Now we have 1500 rows because in the second file we have around 1000 rows, it seems. Also, we are filtering on the shipment date. I will see what is the minimum of shipment date and the maximum ship date. Max of ship date. This is a header being copied. I don't want that header. So where ship date should just contain how many characters? 4, 8, 10. Length of ship date equal to 10 characters. It is a text column, that's why we are not getting the correct value. To date of ship date. DDNM. First, let me convert this data and see. Ship date. Okay. Minimum of ship date. So minimum date is 2011 of year, month and date. January 5th. And same way we'll see the maximum also. Maximum of this date. So the maximum date is 2012. Again, if I load third file also, it will copy it. I will load third file and stop the. Hold 1 second. Hmm. Now I'm loading another file here. Go to this. So the second file was processed 4 minutes ago. Now I have loaded one more file. Let us see if that gets loaded or not. So after the class, you can try with giving the same data, same file name, everything, and see how is it working. Ideally, it should eliminate duplicates. Remember that as soon as you create a pipe, it should be refreshed. Yes, however, otherwise, if you load the files, any number of files you can load, it won't work. First time you have to refresh that. So the file is loaded 29 seconds ago. You can see the table. Our table is order details. Count we can see here. Okay, go to projects. See now prior to loading the third file, we have 2012 November as the maximum date. Now this table is refreshed with the new file. So it has the latest data as 2013. This is how in real time also the latest data keeps on coming into the S3 bucket, and as soon as it is there, the pipe gets triggered and the data gets ingested into this table. This is how we automate the process. So this is just for automating the file copy from S3 bucket to Snowflake. Sometimes there will be insert statements, updates, or some complex joins, everything. But we need to schedule that. Like I need to run it every 10 minutes or at a 10 o'clock every day. Like that, we need to schedule it. For those purpose, we will be using task. Do we have any optimization option for implementing server? Like Snowflake automatically optimizes it. We don't have to do anything in the optimization. Even while copying the data into Snowflake also, it will do automatic optimizations on the background. We don't need to take care of that. Only while doing uh, joins, we need to do the optimization. For copy part, there is no optimization, Samyukta.
Yeah, got you. Sona.
Yeah.
Yes.
Now this snow pipe is completed. You can try with yourself with the sample files and everything. Mm,
Sure.
yeah, this is snow pipe. Next, we have a concept called streams.
It's for CDC, right? Mm.
Yeah, it is a CDC, change data capture. So these streams will be implemented on tables. Snow pipes are implemented from S3 bucket to the table on some files, but CDC is implemented on tables. So just like it will be similar to time travel, but a little difference is there. So time travel, we are able to see how the table structure is before the query execution or before 5 minutes ago or before today. We can see the table structure, but we don't know. By looking at the data, we have to identify what is the delete happened, update happened. We need to compare manually the present data set and the historical data set. We need to compare it manually. But in streams, if we have set a stream on this table, now we have this order details table. If you set a stream on this table, so it will capture everything. If there is an update, it will capture that record along with the status, like is it updated or inserted or what happened. It will do that operation. I will show you. So again, there a new table will be created in the streams. Let us say we have created a stream on this table. There should be object on which the stream has to be created. For now, I'll be creating this stream on this table. I do some operations on this table, insert, update, delete. And if those operations are happening, stream will create a new table with all the details, with the change in the records. We will get a clear idea while we are doing. So stream is also similar. We can create here. Okay, create stream. So this is the sample syntax. I will name this as orders stream. I want to capture changes on the orders table. So that's why I have named it as order stream. As copy grants on table. Copy grants is not required, that is optional. On table, which table I need to do the streaming? Order details. I want to stream on order details. So these options are all optional. So we want to capture at to before timestamp. All these are optional. I don't want any of this. Or if you want to only to see insert operations, now we have to enable this. Only append only is also like insert operation only. Append only equal to true. Then it will capture only the additional any additions to the table. If it is false, it won't capture any additions. So insert only equal to true means it will capture only insert operations. So I don't want anything to define here. I want every change. I'll create this. Create stream. So now the stream is created. Our stream name is this one. This is our stream name. First, we will see this table if it has anything. Go to projects. We can query this stream table just like a normal table. We will see what data is available in this. So it has just the structure, no data at, because after creation of the stream, we did not do any operations on this table. That's why there are no details. Here we have all the table details till here, till longitude and latitude. These are the table details. This metadata action, this column will say what kind of operation happened. Is it update, delete, insert, truncate? What kind of operation happened? This metadata is update. If it is an update statement, then it will say true or false or yes or no. And some row ID. Row ID is like a unique ID for each transaction. I'll do some operations on this table now. First, see, select star from this table. Let us see what we can update or delete. Okay, I want to delete all these text columns. So in the order ID column, it should be just the ID value should be there, but we have this one as well. I want to delete them. Let us see how many are there. Such rows where order ID equal to is capital order space ID. So let us see how many columns are there. We have three columns. Sorry, three rows with such text columns, which are like head. These are actually headers, but we don't want these headers to be in our data. I want to delete them. So three rows will be deleted. Delete from order details where this column is order ID. So it has three columns. Sorry, three number of rows were deleted. Now let us query this order stream table. This is the stream table which we have created on order details. See, this has captured. These are all the table details which we have deleted. Three rows we have deleted. Till here, this is the table data. What kind of action I did on this? I have done delete. So it is all delete operation. So is update. Whatever I did, does it come under update? No, it is not an update, it is a delete. And some unique ID for each transaction. So this is how the stream will capture the data. Now I this stream table will get empty as soon as we copy this data into some other table. Let us run this again. Now the data is there. I'll create one more table. Create table, order stream backup. So in the real time, the operations happen very frequently. Insert, update, delete operations happen very frequently on a large set of data. This stream table becomes huge in every run. So in order to avoid that, we'll capture this into some other table, some backup table. Create table, like I just want to copy the structure, not the details. One second. Okay. I'll do with select limit 0. Okay, I don't do anything. I want the data also into this table. I'm creating a table, order stream backup, with the data available in this order stream table. Now the table is created. Let us see the data here. So whatever is available in this stream table, I have created a new table called order stream backup. So the same data is available. Now again, we'll query this table. I did not delete anything from here, but still it got deleted because as soon as this data is inserted into the other table, it will automatically get cleaned up. So you have to make a note of this. If we have copied it from this table to another table, it will automatically get deleted. Now I have copied from this stream to the backup table. That's why it got empty. Now I'll do some more operations on this table. Let us do select star. Okay, I did a select star. So I wanted to format this date column. Order date, I want to format it into date, year, month, and date. I will update that. Update. I am going to update the whole table. Set. Hope you are familiar with the SQL. Set order date equal to date of order date in the format. This is in existing format. Date, month, and year. So do we need to update all of them or only year 2011? I'll update only some columns, only for a particular country. Where country or region? Better to update the on a region because region will have only 4, I think. Okay, only 3 regions. I'll update only for the north region. Where region equal to north. It will update 476 rows. Let us see. 476 rows were updated. Again, to select star from this table, original table. Just filter out for north. Only north rows were updated. Only the region north column, north rows were updated. Where region equal to north. See, if previously we have first date, month, and year. Now, in the only for North region, we have this thing. The format is changed. Now we'll see what is there in the streams table. What did it do? So this is all the original data of the table. Original means after updating. This is the present table structure. Till here it is the table data, and the metadata action is some are insert. We did not do any insert, but we did only update. Why is it still captured as insert? If you see here, if you see 950 rows were there in the stream table, order stream table, but we have updated only 476. Only 476 were updated, but we have 952. Why? Because this update will be considered as delete and insert. I will show you. The metadata action has insert as well as delete. How it is understanding this update is, first it is deleting all the rows with the original timestamp and then updating that to the format we are defining here. So it will treat it as two operations. So there were 476 rows deleted and again 476 rows were inserted. This is how the capture will happen while we do update. So if you look at this column, if we want to understand, is this really an insert statement, delete statement, or is it an update? That's why we have this additional column to identify if it is an update or not. If there is if this column is not there, then we won't be able to identify if this is really an insert delete or is there an update. That's why we have this. This is how it will be captured in case of update. And this is the unique ID for each transaction. Again, now I will copy this data into, we have already created a table, orders backup, order stream backup, insert into order stream backup, uh, select star from this stream table. From the stream table, whatever is available, we are doing inserting into the orders backup. So as soon as we insert, this stream table gets empty without we doing anything. So 952 rows were inserted. Now this order stream table will have all the history. What did we do on this table? See, previously we have 3 rows inserted into this. Now another 952 rows, total 955. See, all of them are there. These are first 3 rows deleted. It says delete operation happened. If it is an update, no, this is not an update. It is actually a delete. So this is false. And post that update statement is considered as insert and delete and insert. So it is insert, but the update, is it update? Yes. So that's why it is true. All the data is captured in this backup table. We don't have anything in this table unless and until we do some more operations further. This table is empty again. So this is about pipes and streams. In the next class, see now we are inserting manually from orders table to some backup table and this is getting empty. We are doing it manually, but every time it should not be the case. It will happen. It is a continuous process. It happens continuously. I'll do one more update and see. If I do 2 operations without inserting into the orders table, what happens? I will update this to South region as well. I'll update the timestamp for South region also. 463 rows were updated, but in the stream table, it will be double, more than 950. Let us query the stream table. So 926 rows, double of 463. So 920 to 926 rows here, same. half of them are insert, half of them are delete. So again, I will do one more operation without inserting this data into the backup table. So what I will do, let me see what we can update. I'll just update only one row. Update order details set it equal to arrays where I will say where order ID. I'll just update for one record where order ID equal to this one. First of all, let us see how many rows are there with this order ID. Count of star from order details where order ID. So only one row. I am updating this one row. Now query this stream table now. So it is all update. Sorry, insert order ID. What is our order ID? To which record we updated. We will search it like this. We can search the data like this. So why is it two times? Because it is we have performed update on this. It will be considered as delete and insert. So this is deleted. While deleting, what is the value it has? It has Valence as the city. We have updated that with Paris. Paris is an insert statement and Valence is a delete statement. Okay, so if you see here, if we have performed two operations on the table without actually inserting the data into the backup table, still it is holding all of the data. Now I can copy all of them at once. Now I'll copy the data from stream table to the backup table. I have copied it. Now this will get empty. See, this is empty. So without inserting into some other table also, you can do as many operations as you want, but the table gets huge. It would be a better practice if we copy this into the orders backup, some backup table. Yeah, this is about the streams and vibes. Tomorrow we'll discuss task. Task is for scheduling. So here we are manually copying from orders table to the backup table, but we want it on an automatic process. We can do that tomorrow using task. Any questions still here?
No.
Okay.